What is up, amigos? Today we're talking about when is air compressible. So air is a fluid and it is compressible under certain situations. In fact, we can actually say that air is really always compressible, it's just to what degree. And as we speed up air, the density of it changes. And to figure out when air is compressible, we often just say that with the Mach number is above 0.3, then the air is compressible. If it's below 0.3, then it's incompressible. But that's not strictly true, that's just a rule of thumb. To actually figure out when air is compressible by a significant amount, we can actually use this equation here. And this is if we were to accelerate the flow isentropically. So there are no shocks, at least no oblique shocks or normal shocks. So in this equation, we have rho naught, which is the density of air when it's stationary. We have rho, which is the density of air when it's accelerated to the velocity that you're looking at. Then we have gamma, which is the specific heat ratio for air, which is usually about 1.4. And then we have the Mach number, and then the rest are just regular numbers. So if we know what the density of air is here, we can then calculate what the density of air is under different velocities and figure out what that difference is. So to give you an idea of how accurate or inaccurate the rule of thumb that if Mach number is greater than 0.3, then it's compressible. If it's below 0.3, then it's incompressible. Let's think about what happens if the Mach number is 0.3. How much is the density off by? Well, rearranging, or we can put this number into here, and we'll figure out that the density of air is actually about 4.6% different to the density of air when it's stationary. So that means that if the velocity is Mach 0.3, the flow is traveling that fast, then the density of air is almost 5% wrong to what we assume it to be. If we assume it to be 1.2 kilograms per meter cubed, then it's not actually that, it's 1.2, it's 5% off that almost. So that's a huge error. So the rule of thumb saying that the Mach number should be 0.3 before we start considering the air to be compressible, in my opinion, is really outdated, especially considering how accurate our instruments are. And alternatively, we can look at what Mach number do we need to have an error of 1%, because 1% is now kind of where we're at in terms of instrumentation. So if we were to rearrange this equation to figure out what Mach number we would need to get a 1% error, this equation will come out to be Mach number equals the density of air when it's stationary divided by the density of air as it's traveling along, divided by the specific heat ratio, minus 1 to divided by 1, minus 1, and then divided by gamma minus 1 on 2 square rooted. Now if we were to plug in 1.01 into this equation, we would find the Mach number comes out to be 0.141, which is approximately 48 meters per second on a regular day, more or less like within a meter a second. So that means that if we wanted to have only 1% error in the density, as soon as the Mach number goes above 0.141, then we now have a greater error than that, and we should consider the flow to be compressible. Below this, we can assume that the flow is incompressible, and we're only getting at most an error of 1% in the density. So that is when air is compressible, and really how to figure it out yourself. If you have a certain flow at the velocity you know of, you can plug it into this equation and figure out what the density of air change is and whether that is acceptable to you or not, and whether you need to take into account compressibility effects. So if you like this video, make sure to click the like button and the subscribe button, and I'll see you in the video. Peace, amigos.